you very much. It's a pleasure to be here, and thank you very much for inviting to give a presentation. So I share my video. Okay. Okay, I hope you can see my slides. Okay, can you see my slide?
Yes.
Okay, thank you very much. So I'll give a presentation of our project at the CasaPaganini InfoMus Research Center at the University of Genoa. And this first, just a few snapshot of our laboratory. We are in a monumental building, rich of frescoes. Is an ancient building in which we are doing experiment, and I'll try to explain why we are in such a beautiful place with paintings and frescoes. And this is basically our two main rooms. We have other museum rooms, let's say, that are used as a laboratory for our research. There is the former church of a convent, and then there is a room from where we can observe scientific experiments concerning the topics that I'm going to show you. And this is our site, our main room, that is now it is a little bit changed. We have not the chairs. We have a former church that is now a place where we can measure with motion capture, physiology, sensors, audio. We can do scientific experiments. And what is the topic of research, and which is also the motivation to be in such a beautiful place? Because we think that artistic and humanistic theories can be an important source of inspiration for human-centric interactive systems. So for affective computing, to understand emotion, to understand the human behavior at both individual and social level. So how small groups interact and how art and humanities can help to explain and to develop scientific theories and technologies. So scientific and technological results then become a source of inspiration for art, languages, and artistic projects. You can find in my slides also references to some papers in which you can find more information on the topics and on the specific project that I mentioned briefly in this presentation. So this is, for example, a work that we had in occasion of an opera, a music theater opera by Luciano Berio. Is a famous composer of the last century, in the 20th century, that was opening the Salzburg Festival. And he was, we did a complex work for this music theater opera, described also in the papers that you see here. And why we participated to this artistic work. Basically, in this artistic work, music theater opera, the protagonist, David Moss, is a famous singer and performer, was playing the role of the builder of the Tower of Babel. Is a biblical story. And basically, it is a protagonist that has a schizophrenic personality. And so in this music theater opera, we had to collect and to try to measure movement qualities from these main actors, and to understand the emotions and the state of the personality moment by moment, in order to distinguish between the two personalities that were were moving, were changing in this character, from wise to crazy, and therefore it was a study that helped also to understand and to have a perspective of emotion from outstanding artists. So we had on-body sensors, video cameras to recognize this schizophrenic character. And there was and this recognition was used to process in real time his voice in a sort of morphing between a profound voice that corresponded to wise, so a profound and a deep voice when he was a wise personality, versus changes, a morph toward crazy personality, and that was characterized by harsh and high frequency voices, so quite different morphing of the voice depending on the type of emotion and the personality that was expressed during the music theater opera. And this was a very useful work. It was a 6-month work in which I spent 1 month in Salzburg for the Salzburg Festival. And I collected and refined the requirements for a software platform that that resulted after this experience, because I collected several aspects, several requirements, and then we developed it. And after a couple of years, we released the IceWeb software platform that was freely available, and for 20 years with different version, a different evolution, has been a quite widespread software platform for interactive system analysis of emotion, analysis of movement qualities. And we had over 30,000 licenses around the world, also in international research centers and industry, and was used in many fields. You can find again here in orange color, you can find references to this. And more recently, I refer today to European project in which we were involved. Here there is the dance project that I coordinated, and in which we worked with a famous dancer and choreographer, Virgilio Sieni, that he was the director of a Biennale Danza at Biennale in Venice. And we had a long collaboration in which to try to understand some qualities of movement. And this is another project that is called Siempre, in which we participated, and I coordinated this. It was a FET project about trying to understand the musician-musician relationship, and what does explain a correct and engaging music performance from a cold and not expressive music performance. So we studied the relation musician-musician, relation between conductor and musicians, like here you see in the center this is our research center with the orchestra of the music conservatory, and we did experiments with different conductors. And then between music and listeners, so analysis of audiences as you can see from the right picture, and analyzing was with thermocameras. And so in different scenarios in which we developed experiments and to study and to develop computational models and technologies to measure this kind of experiences. This was an invited event at the big European Commission event, the European Future Technologies Conference and Exhibition, in which we were invited to do an exhibition and a performance, and we invited a few dancers in order to exhibit our results in the project. Here I give you an example of what I mentioned very briefly. Now you will hear a string quartet playing a classical music piece. It is just a short fragment. You can see this polygon in yellow that connects the heads of the musicians, and the white lines show the direction of the gaze of the musicians in the string quartet. Okay, so this was the Quartetto di Cremona, is a famous string quartet in our research center, and we were studying in a Siempre project, the European project. We studied what does explain the differences between a music performance that engage an audience, that is an audience receive and appreciate the performance and is emotionally engaged, from the difference with the same music performed by the same excellent musicians, but not engaging. What is the difference between an engaging and not engaging music performance? We found, we did a study in this experiment. For example, we did a sort of trick, I would say, a way to induce this famous string quartet to play in a cold, non-expressive manner. We simply asked the first and second violin to swap their musical score suddenly, without any preparation. So they played the same music fragment that you just listened, in a way that like in a concert in which they express and they are prepared and becomes a single organism. And and then we asked to play, but swapping the musical score between the first and second violin. In that case, since they are excellent musicians, they could play correctly, but they were worried not to be a unified and unique organism playing, but they were more careful to the individual task, so to play correctly and not to convey emotions to an audience. And that was perceived by the audience as a cold performance, not engaging. And we studied the subtle cues in terms of movement. For example, the polygon describing the heads was not anymore a sort of breathing movement of contraction expansion of this polygon. And so they were moving like individual separate elements and separate individuals, and not belonging to the group. And so the movement of the heads were more independent and not having a common breath. And as well, we found a relationship, for example, on the leadership between musicians, moment by moment. So, and it was related on the barycenter of this triangle. You can see now the polygon that emerge from here. For example, there is not a clear leader, but when the gaze change and the barycenter of the crossing between the gaze line goes toward the musician, that is has a correlation with the leadership going toward this musician that is closer to the musician. Okay, so this is An example, a concrete example on how we work to try to develop a computational model and to measure these expressive qualities that we call the mid-level movement qualities. So they are not emotion, not happy, sad, or angry, but something at the lower level. We call mid-level because are up to the physical and the low-level features. So, for example, detect mid-level features are, for example, detect if a movement is rigid, is fluid, is fragmented, is hesitant, is impulsive, and there are some reference to our papers about measuring. This is an example in which we studied these qualities in martial arts experiments and martial arts movement, and we find the differences between a former world champion in karate with respect to black belt teachers. And there was a clear difference in terms of mid-level qualities. And once we develop, with the help of experts and artists, we develop a feature. So how to measure the hesitation or the impulsiveness? How can we validate? One way is to validate mid-level qualities by means of neuroscientific experiments. So we record the features, we measure with motion capture, video cameras, whatever sensors, and then we use our computational model and we compare with the brain images obtained by observer of the same movement. This is a paper, for example, in the center of the page that you can see in Cerebral Cortex Journal, in which we worked with Beatrice de Gelder, and we found that there is a brain signature of lightness. Lightness is a mid-level quality of movement, and we found that any movement but performed with lightness, so to evoke the lack of gravity, let's say, just to give a rough definition, has a similar signature, whatever is the movement, in any observer. And then these are mid-level qualities at the individual level. So how a single individual movement is rigid, fluid, fragmented, hesitant, impulsive, light, and so on. We have a taxonomy inspired also to artistic theories that comes from the work I just mentioned, but also mid-level qualities in small groups, like a dyad, or a group like the string quartet. And we did studies, you can see this to work with my colleagues and other researchers about the measure of leadership and entrainment, the level of sort of synchronization in small groups that explain the quality of movement, like in the string quartet that I mentioned before in a previous example. Another mid-level movement quality is the origin of movement. This is related on the quality. So here you see a boxing. So if you start a movement, for example, from this drawing on the left, you see that the movement starts from the right shoulders and you give a punch. And there is much less strength, much lower performance with respect to the case in which the movement starts from the foot, and then the energy propagates, is collected from the ground, and the energy propagates along the kinematic chain of the body and arrives with a much higher strength and effectiveness in terms of movement performance. But also the arts are a source of inspiration for this feature, the origin of movement. So painters, this is a Giotto painting. In classical painting in our Western painting tradition, classical paintings, you can see that the painters are, let's say, focusing on specific postures that have all the quality of movement in the posture. So there is some kind of implied motion in the painting, in the posture chosen by the painter. The posture are never random, are carefully chosen in such a way that our brain evoke the aspect of the quality of movement. So this mother, what is doing with her hands toward the person that want to kill the child, what is the quality of movement evoked by the arm of the mother, the arm of the fighter. And so we have in these two papers we are inspired by the artistic field, by the sport field, and by of course human biomechanics. Like there is the leading joint hypothesis from biomechanics. So how to measure the origin of movement? This is another example of movement qualities. Once we becomes capable to measure in a more or less successfully the quality of movement, for example, the synchronization like in the string quartet, what can we do with these features? What we did, for example, in another EU project is to measure the movement of people listening to music and doing an experience of active music listening. For example, here is an application that we developed several years ago in a European project about the use of mobiles to measure the synchronization among different users. So you have each mobile phone is a geometric colored shape. If they are synchronized, they evoke a musical instrument. So in all the four, you see the red lines measure the synchronization. Pair of user correspond to a single instrument, and when all are synchronized, so this is electric guitar, then emerge. Okay. This is a sync and move application for mobiles on how to transform the experience of music listening as an active social experience. So to go beyond the digital bubble that mobiles usually put the users. And this is an application in which from music industry, this is another application on the museum field, and in museum how to create an active experience of cultural heritage by keeping into account the measurement of mid-level features of visitors. And this is the this was screen, it was 7 meters. Then when you reach an island, you stand there, and then a building comes out, and then you can select among a series of buildings in the city of Genova. You can have the buildings like you have a travel. Viaggiatore di sguardo means a traveler of the site, travel through the site. And then you see the buildings, ancient monumental building in the city of Genoa, and stimulate to go to visit in person. When you find a building that you like, you just do a simple gesture. The gesture of taking a binocular. So you select, you see you do this gesture, and then you can individuate a binocular. There is a way to understand this gesture, and then there is where you do with your gaze, and then you zoom, you enter into the building, and you explore. You are an explorer, and you can have a visit to a monumental building, and to travel among different buildings in the city, and to raise the curiosity to go to visit in person those buildings. This is just in this quick overview of our project. This is a project on using these mid-level qualities measurements to teach emotion to autistic children. These are two papers that explain the first one here by Piana and others about the system that we developed to analyze movement and to create a serious game to teach autistic children to recognize emotion. And the second paper by my colleagues with two psychologists in our university, and it was on the validation of the system. So how the system was effective and could concretely teach emotion to a number of about 20 autistic children in age 8 to 10, high functioning. And this is a paper that describes how they learned, improved their quality. This was another project, recovering from chronic pain, and it was on measuring and add sonification of your movement in order to improve the rehabilitation from chronic movement. So, for example, back pain, or after an injury, or after a surgical operation. This was done in collaboration with Nadia Berthoz from UCL. And this is the example of the game on recognition of autism, but I see that we are quite late, so I don't focus on it. If you are interested, I can give you the more information, and you have the papers. This one is a not very old European project in which we again use art to help rehabilitation and to improve the treatment. This person is a patient of Parkinson's disease. So how to have patients in Parkinson, how to improve their rehabilitation exercises. This was an exercise that is based on the paradigm that we developed called aesthetic resonance or slow mood. So the person walk in an empty room in the hospital, and instead of doing typical exercise like the stand up and go or something, he can paint and use his body as a brush and to paint on the walls around him. But the painting, his body paint only if the movement is fluid. That is art nudging. Art is a way to nudge the user to move in a fluid way. That is the way that the therapist, the neurologist, aim to achieve. And this is a recent project instead, based on an evolution of our aesthetic resonance paradigm, in which it was aiming at the giving to older people at risk of fragility or with fragility, to induce older people to do exercise, physical exercise and memory exercise. This is the video I leave you. It's quite short, and is self-explaining. It's called Dance Art. It's a project that we started 4 years ago, and then we are still going on this important project that was used in several home residencies and museums, and has a lot of experimentation. The sound is produced by the movement of the person, is related to the fluidity. And she's doing the movement of a mother with a child, with having the hug of the mother with the child. So visual art used as a stimulus to do physical exercise. And it is an exercise that is done in a group. You see that two in the left do not see the painting, and two see the painting. In this case, you don't see very well the painting, but it is the baptism is a gesture of two characters. So we use a painting that has some evoking, expressive, affective gesture that is asked to imitate. How to induce the imitation? Just to have this kind of virtual agent that is derived from the preparatory drawings of the painter. Luca Cambiaso is a famous Italian classical painter. And these the agent is has been replicated from his preparatory drawings of his paintings. And so there is this kind of tutor of this virtual agent that emerge from the painting and teach step by step the movement of the hug of the mother with the child. These are the steps that are shown, and there is a teaching to the users. And then at the end, you dance the affective gesture of the painting. And this is how the tutor explain emerging from the painting. This is how it is. And the painting re-emerge by the light of candles, that step by step, if you continue to do the movement with the correct fluidity and the correct type of gesture, then the painting is reconquered, let's say. You reconstruct the painting. And this is a way to invite also to invite the participant to visit the sites, the museums where the paintings are possible to live, to see in a physical place, in a physical visit. And there are some papers also in which we measured also the effectiveness in terms of the results after a series of sessions with the system. This is something related to the how the system is is developed, how to build the storyboards, how to design the storyboards. Okay. Okay. And then, so this is I think that I'm going to conclude, given the time is concluding. So this is the interactive sonification movement qualities and the use of visual art to, let's say, to induce and to nudge and to have an aesthetic resonance with art in terms of visual art and sonification. Here you have 3 papers that explain our paradigm of aesthetic resonance, and we adopted and we developed experiments and theories that are beyond behind the system. And this is about the validation, how to validate models of interactive sonification movement qualities. These are some papers in which we create sonification. The sonification is not music, it's just the translation of movement quality into the auditory domain according to scientific theory of cross-correspondence between modalities, between sensory channels in the human. This is, for example, studies that we did with the choreographer Virgilio Sieni, in which we studied and we developed a data set on movement that are light, like on the left. This is a movement that is light, and we created sonification of light movement. And you can see this is an example of light movement. Then you have, in the other, you have frail movement with a lot of cracks and an interruption. And we have several projects about this. So I think that this gives you a brief overview of some of our projects. We, in our research center, we host a new transdisciplinary master degree at our center of University of Genova. Is about digital humanities, and the track it is an international track on affective computing, arts, and cultural welfare. And it is an international track of this master degree, in which we have also international students, and it is, and they work in our research center, and they participate in some ways to our research center. And so these are my references in case you have questions or you have any curiosity or to receive further information. And there are 3 projects that I mentioned, and the Resilience is a project that is ongoing, and Entailment is a project I didn't mention, but is about the study of individual as well as group movement features and multimodal analysis of such features, and that I coordinated, and the Danzarte, that the project on the experience of visual art and sonification, and for physical exercise and memory exercise for older people, and it is based on the aesthetic resonance paradigm. So I thank you very much for your attention, and I remain at disposal for anything, any possible question.
Okay. Thank you very much for your time and great lecture. Okay, connect 이상하 교수님.
Hi, Antonia. Thank you very much for that interesting talk. My name is Sang Lee. I am an associate professor at the Department of Brain and Cognitive Sciences at Seoul National University. I don't know if you remember, but we had actually been like in the same Zoom meetings a couple of years back when Professor Kim Young-suk and we were all kind of discussing aging and having these kinds of multimodal data collection in museums.
Nice to see you again.
Hi.
Hi.
For me, as a kind of a brain and cognitive scientist, I thought I was really interested by the fact that you can pick up on not the kind of movements that you can immediately like identify as this is positive or this is, happy or sad, but to kind of tie it to a defined emotion, but the mid-level movement features that you're looking at, like the rigidity or fluidity, maybe speed and kind of hesitation or this kind of movement features. And I was trying to imagine some cases in which that might be context dependent. Like, so maybe you're picking up on things that are social in a social interaction, but whether you are in a restaurant with your coworkers, even though it's pleasant, may look very, very different in terms of these kinds of movement features from, let's say you're, I don't know, on the picnic with your children and your dog. And so how do we get away from having to like take these kinds of measurements and features for every single context there is? I guess my question is about the generalizability of these kinds of findings.
Yes, it's a very interesting question. Thank you. So what we are trying to do is to contextualize the features. So we try to understand, for example, lightness is something that can be measured independently from the context. Is a mid-level feature, and then you can interpret what does it mean light movement in different contexts. And that is the contextualization. I think it is at a higher level. It's a layer. We work at the different layers. So what you mentioned is the contextualization. That means that you go beyond and to interpret the mid-level feature in a given context. And that can be this information that is at mid-level can be interpreted and can be adjusted according to the personality of the person, the social relation of the person, and the social context. So you need to work at the longer temporal scale. And this gives these mid-level features, which are usually at there is also a sort of layering of different temporal scales. This was the topic of the Entertainment European project. We worked 4 years on this, and mid-level features are usually between a half a second to a few seconds in a range of scale. And then you have an information, some quantification that you have to reinterpret in a context maybe of 20 seconds or a few minutes, and according to the general also environment in which the features happens. So you are right that the mid-level features are not the final result, but are something that can be, for example, the input vector to a machine learning or deep learning model in order to interpret. But this deep learning model should be, in a sense, configured to some kind of context, because it's very difficult to generalize and to having something that works in every context. That is something that is too much, at least for us, to conceptualize. But you touched a very important topic and research direction in which we are very interested, and we would be pleased to have a collaboration your groups and in Korea, and to have maybe a joint Italy or European Korean collaboration. Thank you.
Thank you. I'm going to just help field questions. Professor Kim asked me to do that. Perhaps if there are other questions, please feel free to raise your hand to the audience. And if there are any students who are too shy to speak out, you can put your questions in the chat. And if there's anything I can do to I don't know, help communicate, I'd be happy to. So please, whoever has a question, please go ahead and speak up.
I can ask one question. Thank you very much, Professor Antonio Camurri. I'm Kyung-Sik Khan from Hanyang University, same university as Professor Kyung-Soo Kim. I'm in the Department of Data Science. Very inspiring talk. I like a lot of your project related to human movement and understanding that in terms of the emotions and a lot of things. One question is, since I'm studying artificial intelligence, so there are a lot of generative AI and even LLMs out there. And I was wondering, have you considered integrating or using some of those technology into your work, and try to understand how these technology can be used for better understanding like the human movement, and that the interpretation of the movement related to their emotions and performance and so on, and interactions?
Yes, thank you for the question. Again, it's very interesting. My talk, I tried to summarize, and I did not enter into the details of how we measure the features or how we model the interaction or the sonification. Of course, we are using machine learning and deep learning. For example, we have studies in which we compare, let's say, shallow models with deep models in order to find the most effective way to recognize a given feature. For example, there are a few papers on this topic, and the origin of movement, for example, is based, measuring the origin of movement is based on, we are currently using an integration of game theory and graph theory, in which the body of the person is a graph and the joints are the players. That the player that is at the highest role is the origin of movement candidate to be, but is not enough. So this become the different role of the players becomes part of the input vector to a machine learning model, in order to have a better. So we are using in different ways machine learning techniques with other kind of techniques. And this is a research, there is a series of research challenges. And if you're interested, I can give you some links to papers in which there are explanation of our computational models. And of course, I would be very interested to know about your work your work, and also Sang Ali and Professor Kim. If you have any papers that we can read, and maybe have a sort of a way to start a sort of scientific bridge between our groups, I would be very interested to read some papers, or having any input from your group.
Thank you.
Thank you very much. Yes, I mean, we would love to continue some more discussion in the future. I had too many questions, so I don't want to be selfish. So let's open up the floor to any other questions the students or anyone else might have. Okay, just to kind of wrap up, I wanted to mention this kind of my own selfish desires, that because I work a lot with children and older adults in looking at the interaction between like memory systems and development, the developing brain. And one of the things that we are very keen on is to pick up on cues that are nonverbal. They're not about, like answering certain questions right, but picking up on these kinds of features that might reflect something more about the internal processes going on in children and, maybe in patient populations that cannot verbalize exactly what is going on inside them. And I think this whole kind of your interdisciplinary approach is, I think, has so much potential. And so hopefully in the future, those of us here in Korea and related to the center can discuss with you further on potential collaborations. Thank you very much.
Yes. It's very interesting, and it is very important. Is one of our core research interests, because we work on nonverbal. And another aspect that you have seen that I mentioned, the children and older people, which are the two periods of life with a higher fragility. And this is the focus of our research center and the motivation of our research center, just to focus on these two periods of life. And we are very interested on the nonverbal component, nonverbal communication. For example, in the Danzarte project that I very briefly shown with the art, visual art paintings, there is a very interesting results in term. There are very interesting results in terms of the effect of also social bonding that get emphasized and reconstructed in older people that become let's say isolated, and instead with this it creates a sort of social bonding, reconnection with others, or to create caregiver patient bond and social link, and with a higher amount of movement, mid-level qualities that explain also the improvement of the patient in this case. And also with we found very interesting results with intergenerational aspect. With we did experiments in 10 home residencies for elderly people with dementia or Alzheimer, and we found concrete measurements. One of our papers is with the clinicians, with geriatrics, and that did some measurements of the effect of a series of sessions for a longer period, and what happens with respect to a control group. And and we are very interested to go further in this direction in both aspects, with children, older adults, intergenerational. These are of very high importance for us, and I would be very pleased to consider and to start brainstorming on concrete ideas about possible future collaboration.
Excellent. Thank you. Professor Kim, would you like to?
Okay, we deeply appreciate him for preparing today's outstanding lecture, and I sincerely look forward to our continued collaboration on meaningful research. Thank you.